really old library I wrote, 7 years old. I wrote this, I'm doing this because I've seen this talk by you, and also yesterday that there's a big interest here in this recursion schemes and generic programming also. So I wrote this library when I was learning about recursion schemes, and my motivation was exactly the same problem you had. I wanted to annotate my trees with extra information. So I made this, but then I realized that I also wanted to do like not just recursion schemes, but generic programming in a more general sense. So I recognized that if you add not just functor, but also foldable and traversable, then you can do full generic programming. So let's see the demo. So this is, everybody can read it. Okay. So all the language extensions are just for convenience. They are not necessary. So the actual library is Haskell 98 compatible because I like purity. So I have the same standard example of an expression tree, very simple. So I use GHC deriving everything because I'm lazy, but you can write it yourself. If you want instances of egg or show read for the tree type, the fixed point type, you need to add these 4 lines only.
So it's already on Haskell 98.
Where?
If you're deriving all these classes,
that's
already on Haskell 98.
I mean, this you can, this is Haskell 98, this you can write yourself. But I'm lazy. Okay? So yeah, there is more non-Haskell 98 for convenience, but this is just that I can show it fast. And then I have my example, which is just a very simple expression. So let's run this code. Let's see. Maybe I move this up. Oh, no, okay, you can see it, I guess. So, so we have this thing. There's a show instance. There is an equality instance. There is a read instance. Oops. Yeah, so read also works. Okay, but we can do more. Like, try this. Oops. Oh, sorry. Maybe I don't need this. Oops. The code was what you've seen, there is no extra code. You can do the same with graph list. I did this already, so there is something like this. And I already exported this into a file, so I can show you this works. You can have more things. There is a zipper, which works for any tree. There is a trie data structure, so generally there are tries for trees. You can have all these adding annotation stuff you talked about here. There are the standard recursion schemes, but there are also these more generic traversals, so you can change the structure of your tree. It's here somewhere. Yeah, so you can do all the stuff you want. So basically that's it.
Okay, thank you.
Oh yeah, one more. There is also pretty printing. So pretty printing works. So for that, of course, you need to specify how to render. So this is the specification. So you specify the fixity, associativity, and how to render the nodes, and then it can render pretty clean. You could probably do a parser, but it would be more complicated. But I already have a parser because read is a parser, so it's just technical difficulties of precise parsing and stuff like that. Yeah, that's it.
Okay, thank you. Any questions for you? No? Yeah.
What did you use it for?
Nothing. I wanted to use it for symbolic algebra like that, and maybe very simple DSS. Of course, because it's this functor approach, it's very limited. I mean, you can have just one data structure, just simply requisite. But it works actually for symbolic expressions, symbolic mathematical expressions.
And the fun starts when you start doing symbolic differentiation and simplification.
Yeah, you can do simplification. I mean, there is hashing. You can hash any subtree generically. You annotate with the hash. You can do common subexpression elimination. You can do symbolic differentiation. Yes, like I tried these steps. I haven't implemented a big project, but that was the motivation. So that was the intention, and it works.
Okay. Another question?
How does it relate to recursive schemes? Is it the name of the advanced library?
I haven't compared. I guess, those parts are pretty standard, so I guess it's the same basically. It's less general because I don't have the base type family. I have all these things somewhere here. I have no idea how it's called. Yeah, you have all these kata, para, ana, apo, hilo, zigo, whatever, histo, futu, whatever. I don't understand either. I understood it just to implement and I immediately forget. I find it boring. I wanted to do generic programming like this. And yeah, you have monadic, whatever. But I mean, the problem is it just blows up. You have so many combinations. It's hard to find a good API for this. I wanted to find a unified API for all these. And I had an idea, but then I haven't.
This is the point of the unification article I was linking, that you can, in theory, come up with 3 recursion schemes, one for the consuming the tree, one for creating, and one for threefold, and you get all these as special cases.
Yeah, so for me, this was, as I said, it was a learning experience. I wanted to learn. Basically, what I wanted to do is do generic programming a la Uniplate and add annotations. So I had to translate everything to fixplate to be able to add annotations with the coffee thing, and then this just came out. That's it.
Yeah. Thank you.